The ESP32 development board has a total of 30 pins that interface it to the outside world. These pins are classified as follows. Power pins. There are two power pins, V-in pin and 3.3 volt pin. The V-in pin can be used to directly supply the ESP32 and its peripherals if you have a regulated 5 volt voltage source. The 3.3 volt pin is the output of an onboard voltage regulator. This pin can be used to supply power to external components. GND. This is the ground pin of the ESP32 development board. You can supply all the common ground to various sensor and modules, I2C and SPI. The I2C and SPI pins are used to hook up all sorts of sensors and peripherals in your project. I2C stands for I2C. It is a serial protocol for a two-wire interface to connect low-speed devices like microcontrollers, EEPROMs, analog to digital and digital to analog converters, input-output interfaces, and other similar peripherals in embedded systems. It was invented by Philips and now it is used by almost all major IC manufacturers, whereas SPI stands for Serial Peripheral Interface, which is a synchronous serial communication interface specification used for short distance communication, primarily in embedded systems. The interface was developed by Motorola in the mid 1980s and has become a de facto standard. GPIO pins. ESP32 development board has 25 GPIO pins, which can be assigned to various functions programmatically. Each digital enabled GPIO can be configured to internal pull up or pull down or set to high impedance. When configured as an input, it can also be set to edge trigger or level trigger to generate CPU interrupts. ADC channels. The board integrates 12-bit SAR analog to digital and supports measurements on 15 channels which are analog enabled pins. Some of these pins can be used to build a programmable gain amplifier, which is used for the measurement of small analog signals. The ESP32 is also designed to measure the voltage while operating in sleep mode. DAC channels. The term DAC stands for Digital to Analog Converter. The board features two 8-bit DAC channels to convert digital signals into true analog voltages. This dual DAC can drive other circuits as per your project requirements. Touchpads. The board offers 9 capacitive sensing GPIOs, which detect capacitive variations introduced by the GPIO's direct contact or close proximity with a finger or other objects. UART pins. UART stands for Universal Asynchronous Receiver Transmitter. ESP32 development board has two UART interfaces, that is UART0 and UART2, which provides asynchronous communication RS-232 and RS-485 and IRDS support and communicate at up to 5 Mbps. UART provides hardware management of the CTS and RTS signals and software flow control X on and X off as well. SPI pins. SPI stands for the Serial Peripheral Interface. The SPI pins of ESP32 features three SPIs: SPI, HSPI, and VSPI in slave and master modes. These SPIs also support the following general purpose SPI features: four timing modes of the SPI format transfer up to 80 MHz and the divided clocks of 80 MHz up to 64 bytes FIFO. All the SPIs can be used to connect to the external flash or SRAM and LCD. PWM pins. The board has 25 channels. Nearly all GPIO pins or PWM pins controlled by the pulse width modulation controller. The PWM output can be used for driving digital motors and LEDs. The controller consists of PWM timers and PWM operator. Each timer provides timing in synchronous or independent form, and each PWM operator generates the waveform for one PWM channel. EN pin. This is used to enable ESP32. The chip is enabled when pulled high. When pulled low, the chip works at minimum power.